Okay, so let's consider another example. This is a simple example actually, you don't have to do many job here. Let X have the PDF f of x theta with mu equals 2 theta and sigma square equals 2 theta square. Here let y equals summation xi be a complete sufficient statistic for theta for a random sample of size n. Here, part A, find the minimum variance unbiased estimator of theta. Here, we already know that summation xi is a complete sufficient statistic, so we don't need to find that step. So only thing that we have to consider is expectation of y and see what's the form of that one. If it is a function of theta, it's very easy to do that. So expected y is expected summation xi. Okay, so we have n times 2 theta. So this means that when we have y over 2n, we will have an unbiased estimator of theta. So y over 2n is the minimum variance unbiased estimator of theta by Lemma-Scheffer theorem. Okay. Okay. So part B. Find the minimum variance unbiased estimator of theta square. Find the minimum variance unbiased estimator of theta square if it exists. Okay. So we know that expected y is a function of theta. Then expected y square can be a function of theta square, right? So we consider that. And actually here, since we have y over n, which is x bar, so we can use x bar. Using x bar is much more easy compared to summation xi. So since variance contains theta square, consider summation xi whole square, or writing this one is easier. Okay, so consider expected x bar square, which is variance of x bar plus expected x bar whole square. What was the variance? It is 2 theta squared, it's already given. What is the variance of x bar over n? We have to say over n. 2 theta, take the square of that one. So what we have here is 2 plus 4n over n theta square. Okay, so it's easy to keep theta square alone here. If we multiply x bar square by this, we will have theta square. Now, x bar is a complete sufficient statistic. So we find the unbiased estimator of theta square as a function of complete sufficient statistic. So by Lemma-Scheffer theorem, we again say that n 2 plus 4n x bar square is the minimum variance unbiased estimator of theta square. Okay, so we have part C. This one is a bit difficult one, so be careful about this. So consider expectation x1 plus x2 given y. What is this? So it's a bit difficult to think actually. So here, this expectation should be a function of y, right? It should be a function of y. First of all, we know that. And we also know that expectation of conditional expectation gives us an unconditional expectation, right? So it is same as this one. So first of all, let's find this. Okay. So what is x1 plus x2? What is the expectation of x2 theta? So 2 theta plus 2 theta, we have 4 theta. Okay? So we know that this expectation expectation of this function should be 4 theta. And this function itself is a function of y. What is y? Y is a complete statistic, complete sufficient statistic. But here important thing is to be a complete. Okay, so y be a complete. So since y is complete, it helps us to get a unique result. Okay, so then this means that there can be only one function of y whose expectation can be 4 theta. Okay, because when we have a complete statistic and considering the expectation of these statistics, there can be only one unique function of y which satisfies this expectation. Okay, so since y is complete, then there can be only one function of y which is an unbiased estimator of 4 theta. Okay, so what is y? Y is summation xi. So we have to consider expectation, some function of summation xi whose expectation of 4 theta. Okay, so what is expected y? Consider that it is 2n theta. So we want the expectation getting 4 theta. Okay, so to be able to get 4 theta as a function of y, okay, we have to multiply y by 2 and divide by n, right? Then we will have 4 theta. So we have a function of y whose expectation is 4 theta. Okay, so whose expectation means expectation of conditional expectation is 4 theta. So this means that this expectation x1 plus x2 given y should be 2y over n. Okay, or 2x bar. Okay, so I hope you understand how we solve the problem. If you cannot, so we can discuss it on Wednesday. So let me stop here and continue with more examples. So you will see many different examples actually in this part.